Recording going now, adjusting my phone to a better angle. All right, hi, welcome Year 10. I am going to talk about standard deviation and give you an example of calculating standard deviation. Now, the technical definition you'll find in your text is a standard deviation is a number that describes how far data deviates from the mean. Standard deviation. So it's a measure of dispersion. And as a measure of dispersion, it is trying to measure how spread out your data is, how varied it is. So measures of dispersion generally, an example I sometimes give is you're walking down the street and you're trying to work out the age of people. Well, if you're walking down the street in gallery walk or whatnot, you're going to find that you'd have a large range of ages there. So range is one of your measures of dispersion, so is interquartile range. This is a third way of measuring how spread out your data is, standard deviation. So standard deviation differs a bit from the other two measures I just mentioned. Range, you're only calculating that off the maximum and the minimum. The maximum subtract the minimum. In the quartile range, it calculates it off, well, the third quartile subtract the first quartile. So you're only actually running it off a couple of values. But here, in the case of standard deviation, you include every single value in your calculation. And that way, it is a little bit related to mean. Remember that mean uses every single value in its calculations as well. So, to cut a long story short, there is a big, hideous formula that you are being given to calculate standard deviation. Now, your symbol here, by the way, and I'm going to have a brain freeze. I think it's omega, but apologies if that's wrong. Correct it in the comments of the video. This symbol is always used to refer to population standard deviation. So you may remember previous year's discussions about populations versus samples. So, you know, if I wanted to know student opinions on the uniform, do you like the uniform or not? If I was surveying the population, I'd have to survey absolutely every student in the school. I might instead do a sample, right? So populations versus samples becomes very important in statistics, particularly at university level. In case you're curious, the sample standard deviation also has a standard symbol, and that symbol is S. So if you ever see S in any documents, statistical discussions, or anywhere else, S refers to a sample standard deviation, and population refers to a population standard deviation. So the formula given in your text, hideous looking thing, looks a little like this. X1 take x bar squared plus x2 take x bar squared plus however many values you have after that plus xn take x bar squared. So all over n. Now some of the symbols here I hope you're comfortable with from our previous adventures. So, thought I'd knocked it over there for a sec. Wouldn't have been good for any of us. Right, so some of the symbols you should recognise here. X bar. If I was interacting with you, I'd go, what's X bar mean? Well, it is mean. And you should also remember the formula. It's the sum of your values divided by the number of values. In there, I've just given away what one of the other symbols here means, this n. N is the number of values. So those bits are not new. What's new in there, besides that symbol at the front, of course, that I talked about just before, is this x1, x2, up to xn. Those represent your individual pieces of data. So x1, x2, x3. xn just means any piece of data, really. It's a general case of a piece of data. They're your data values. So with that in mind, let's do this. We need to do some data, get some data for finding out, finding out standard deviation. What data should we use? Anyone have any ideas? Oh, well, I might make up some data now. I'm just not creative on the fly. This is one of these things where I need to be standing in front of you and going, oi, give me some ideas. What do you want to talk about? And we talk about shoes or whatever. Oh, there we go, shoe sizes. Here we go. I've sampled our class and I've got some shoe size data. How many of us are here at the moment? In fact, I'm just going to check, let anyone in who's waiting. There we go. So let's say I sampled, I'm only going to take, 6 students for now, because this is a pretty painful process. I surveyed your shoe sizes. I got someone with a size 10, a size 6, an 8, a 9, another 10, and a 13. There we go. So before I use this formula, I'm going to work out some of the values that I need to put in it. So firstly, I'm going to, n's pretty easy. How many values are there? 1, 2, 3, 4, 5, 6. Fantastic. Secondly, I need the mean. So I'm going to find the mean. Sum of the values divided by number of values, so it'll be 10 plus 6 plus 8 plus 9 plus 10 plus 13, all over 6. So the mean is going to be, I'm actually just pulling up Excel quickly, plus 6 plus 8 plus 9 plus 10 plus 13 divided by 6. 10, 6, 8, 9, 10. Yep. And it's telling me 9.33 recurring. All right. So to be accurate, I will retain the recurring on it for now. Now I'm ready to use the formula. And this is going to be big. So theta is equal to the square root of, oh man, this isn't going to be good. I don't have my calculator on me. So here we go. The first value, so x1 refers to the first value. I could put labels on it, right? This is x1, x2, x3, x4, x5, x6. So we put them in the formula. So it's going to be 10 subtract your 9.3 recurring squared plus second value 6 take 9.3 recurring squared plus 8 take 9.3 recurring squared plus 9 take 9.3 recurring squared plus 10 take 9.3 squared plus 13 take 9.3 recurring squared. Now, does anyone know why we'd be squaring all these values? I'll give you a hint. It's because we want them to be positive. Squaring it forces these values to be positive. Like, think about that. That would be a negative value. If I didn't have a squaring here, that would actually end up to be a particular value. If you're particularly creative, do you know what it would end up to be if I didn't square all those values? Pause for a moment and think about it. It would end up being 0. So, all of that, of course, needs to then be divided by 6. Now, I'm going to do something risky here on the video side of things. I'm actually going to load up Excel here, and in Excel. Now, I hope someone at home puts this in their calculator. If you can see that, can you please put that very large formula in your calculator? I'm recording videos. It's all good. All right. And in Excel, it's something like, was it standard dev.p to get the population standard deviation. There's also a .s. And in theory, if you put that in your calculator correctly, I've just done it using Excel in the background, sorry to be a terrible cheat, it's telling me theta is 2.134. So it's saying the standard deviation is 2.134. Now, if that data was more variable, if we had, a couple of size 2 shoes in and that sort of thing, the standard deviation would be larger. If pretty well everyone had size 9 and 10 shoes or similar, it would be smaller. Standard deviation in concept is similar, but not exactly the same as the average distance from the average. And that gives you something to think about. It's not exactly that, but it's similar to that in concept. The other thing I'll point out is I mentioned before how there's a population standard deviation and a sample standard deviation. In the formulas, when you see it, the only difference is sample standard deviation actually has n subtract 1 on the bottom there rather than just n. That's the only difference in the formulas. In effect, what that does is the sample standard deviation, it encourages this to be a bit bigger because there may be more variance out there than you're sampling, because samples are limited to your whole sample when you're trying to judge about a population. But that's all an issue for another day. For now, this is the way that your text is shown it. Another very common way of calculating standard deviation by hand is to do up a big table. And what they do in the table, if I remember correctly, is in each one, if you did it as a table, you'd have your x values. So, you start off with your values like 10, 6, and 8, and so on. They'd then you'd work out your average and put it there. Then you'd work out your x value, subtract the mean. So, for example, on the top row, you'd have the value of 10, you had a mean of that, you'd then work out what that is, it'll be 0.6 recurring. The next column they do is they square it. So you'd square that value, whatever you get, and in the end you wanted the sum of all that. So at the bottom of the table they'd have a total. The value there is that entire top row in the formula. So from the table you get the value for the top row, divide it by n, square root, and that's it. You do not have to do it the table way. I'm just saying, in case you look at anything on the internet or you look at videos, yeah, there is a table way of doing it. You set your headings to be something like that. You work down, you get a total down here, which is that line. But you don't have to do that. This is the way the text is shown you. Find n, find the mean, shove it in the big formula, get your population standard deviation. Thank you for listening, and I hope that made sense. Cheers, year 10. Just quickly, while I'm here, for the record, I would never write that formula the way the text does. I actually would have written that huge formula like this. Theta is the sum of each x value, subtract the mean, squared, divided by n. So this is not in the text, but it's a cleaner way of looking at the situation. You're actually just adding up, for each value of x, you're adding up, well, that value, take away the mean, each value, take away the mean squared. That's that top line. It's just repeating itself. Each time you write a bit of that formula, it's just repetition that isn't necessarily needed, but that's the one that's in your text, so that's the one you're going to see for the time being. But if you see it written in that form, don't freak out. It's the same thing. It's saying add, for each value of x, add that expression together. That's all. Thanks. Bye.